Hello. Today we're talking about lesson 11.1, angles and fractional parts of a circle. So the essential question is, how can you relate angles and fractional parts of a circle? So if you have fraction circles, that's what we're going to use right now. And it says place a 1/12 piece on the circle. Okay, so I put 1/12 there, and then trace the fraction piece to create an angle. Okay. So that would be our angle formed right there. Okay. And now what parts of the fraction piece represent the rays? What parts of the fraction piece represent the rays? The straight sides, right? These parts right here, those are the straight sides of the rays. Where is the vertex of the angle? Well, it's at the center of the circle. Remember, the vertex is the endpoint that is shared by both rays. So shade the angle formed by the 1/12 piece, label it 1/12. So if we go around, that would be 1/12. And it says continue to do that. Continue to turn it counterclockwise until you get back around. So 2/12s, 3/12s, 4/12s, 5/12s, 6/12s, 7/12s, 8/12s, 9/12s, 10/12s, 11/12s, 12/12s. Okay, and we can confirm that it takes 12 pieces to make up the whole circle. Okay, so it says trace the fraction piece in its new position. How many 12ths have you traced in all? So at that point, we had traced 2. So I had 2 12ths shaded. Now, how many are there if we keep going around until we get back to where we started? Well, there are going to be 12 sections, right? 12 12ths. How many times do you need to turn 1/12 to make a circle? 12 times. How many angles did we make? Well, each piece, it was an angle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 angles. So now compare the size of the angle formed by a 1/4 piece and the size of the angle formed by a 1/12 piece. Use a 1/4 piece and your model on page 441 to help. So if we put 1/4 down, we notice that it covers 3/12. Well, so if I use a 1/4 piece, we notice that it takes up 1/4 space. And so if we turn the 1/4 around, we notice that it would be 4 turns. So it takes 3 sections. So these three would be 1/4. These three would be 1/4. These three, 1/4. And those three, 1/4. So what is the relationship? The size of the angle formed by a 1/4 piece is 3 times as large as a 1/12 piece. The size of the angle formed by a 1/4 piece, the size of the angle formed by a 1/4 piece is 3 times as large as the angle formed by a 1/12 piece. So if that's the 1/4 angle right there, it would take me 3 of the 1/12s to equal it. Describe the relationship between the size of the fraction piece and the number of turns it takes to make a circle. So let's look at if it was a third. It would take me 3 turns to get around a circle. 4 turns. 5 turns. So there's 5 fifth size pieces, 5 turns. So the smaller the fraction gets, the more turns it takes. Remember, the larger the denominator, the smaller the fraction gets. The smaller the fraction size, or the smaller the fraction piece, the more turns are needed takes to make a circle. Okay, here 1/12 would take me 3 turns to go just 1/4. All right, you can relate fractions and angles to the hands of a clock. All right, so let the hands of the clock represent the rays of an angle. Each 5-minute mark represents a 1/12 turn. Okay, so every time 5 minutes, each of the numbers on the clock is worth 5 minutes. So this would be 5, 10, 15. So 15 minutes have elapsed on this clock. The minute hand makes a 3/12 turn or 1/4 turn clockwise. Clockwise, going in the typical direction of the hands on a clock. The red arrow on the outside tells me which direction the angle is opening. 30 minutes have gone by. 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, or a half a turn. 45 minutes. Well, there's 1/4, 2/4, 3/4. So 9/12 or 3/4 turn. And then if it goes all the way around, that would be 12/12 or 1 whole turn, 1 full turn clockwise. Tell what fraction of the circle the shaded angle represents. Okay, so the shaded area is filling the top part of the circle, and that would just be half the circle. How about this section right here? Well, that would be 1/4. How many 1/4 are in this one? There would be 3. Let's see what I do with my fourths. Yeah, it's not big enough. So that's not what I wanted to do. 1/4 turn makes a 90-degree angle. $90. So those are the 3. So 1, 2, 3/4. 4 is just 1 full turn. So just 1. I guess if we're writing it as a fraction, we could say 1/1. Number 5 is half. And number 6 is 1/12. Okay, this would be 1 o'clock on a clock, right? That's pointing at 12. This is pointing at 1. So it would be 5 minutes. So 1/12. All right, now tell whether the angle on the circle shows a quarter turn, a half turn, a 3/4 turn, or 1 full turn, clockwise or counterclockwise. So if the red arrow is going to the left, that's counterclockwise. So, and this is a 90-degree angle, so that's 1/4 turn counter clockwise. Go ahead. So it's opening in the opposite direction that the hands on a clock would go. Here we're going clockwise. That is the way the hands on a clock go, and it's gone halfway. So it's made a half turn clockwise. Okay, here 1, 2, 3, 3/4 turn clockwise. All right, number 10. Susan watched the game from 1 p.m. to 1:30. Describe the turn the minute hand made. So we're starting at 1 and they wound up at 1:30. So the minute hand went all the way around to the 6, and so that would be a half turn clockwise. Number 11. Compare the angles in exercises 1 and 5. Does the position of the angle affect the size of the angle? 1 and 5. So 1, we have half the circle here. 5, we have half the circle here. Well, it's still half, right? So no, it doesn't matter. No. Both angles represent 1/2 turn. Well, I'm sorry, 1/2 of the circle equals 1/2 of the circle. So the position doesn't matter. Number 12. Malcolm drew this angle on the circle. Which of the following describes the angle? Well, it's counterclockwise, right? It's going to the left, so it's definitely counterclockwise. And how many turns did it make? It made 1, 2, 3. So it made a 3/4 turn counterclockwise. Whose statement makes sense? Whose statement is nonsense? The shaded angle represents 1/4 of the circle. So this is the shaded angle. Okay, that's definitely 1/4 of the circle. So the shaded angle represents 3/8 of the circle. No, because it's not going to take 8 pieces. Not going to take 8 of these pieces to go around the circle. So um, so hers makes sense. If we were to divide this circle into 4 equal pieces, then this shaded part would be 1/4 of the circle. Adam's statement is nonsense. So if we combine, let's look at a fourth. Okay, so hers was a fourth, and we're saying that instead of fourths, it's going to be broken into 8 pieces. How many eighths is equal to a fourth? 2/8. 2/8 is the same as 1/4. So this would not be 3/8. It would be 2/8. All right, for the statement that is nonsense, write a statement that makes sense. The shaded angle represents 2/8 of the circle. What is another way to describe the size of the angle? All right. So instead of 2/8, what could we say? Again, how many 12ths would equal a fourth? 3, right? Okay, so 3/12 is equal to 1/4. 3/12 is equal to 2/8. So we could say it is 3/12 of the circle. All right, so that's our discussion of initial discussion of angles and fractions, fractional parts of the circle. Okay. So our next lesson will cover degrees in lesson 11.2. So until then, may the numbers always be in your favor.